Hello everyone. The present topic atoms and molecules, module 3, atomic and molecular masses and mole concept. This is useful for the students of grades 7th to 9th. Please subscribe my channel, like and share. Atoms are very small and it's very difficult to find their mass or size. To understand the size or mass of an atom, let us have some comparisons. Size, if you take an apple or pomegranate, it is about 10 to the power minus 1 meter. 10 to the power minus 1 meter means 10 centimeters. And mass about 60 to 100 grams. If you consider a small ant, its size is about 10 to the power minus 3 or 1 millimeter. Atom is so small. Its size was found experimentally as 10 to the power minus 8 to 10 to the power minus 9 centimeters. 10 to the power minus 8 centimeters is equal to 1 angstrom unit. All the matter of different types is made of atoms. Thus, the parameters of atom, that is size and mass, should be known for further studies. If millions of atoms are stacked together in line, they are as thick as a sheet of paper. So if you want to find the thickness of a paper, it's not possible to find. Whereas if you take a book, count the number of pages and find the thickness of all those papers and divide, then you will get the thickness of the paper. Now let us discuss some in the previous module we discussed the laws of chemical combination, that is law of conservation of mass, law of constant proportions, law of multiple proportions. Now the law of constant proportions stated that the elements combine in a fixed ratio by mass to form a compound. In the formation of water from oxygen and hydrogen, 1 gram of hydrogen combines with 8 grams of oxygen. That is, the mass ratio of hydrogen to oxygen is 1:8. Dalton's atomic theory proposed that each element has a characteristic atomic mass. Since atomic mass is very small to measure, a concept of relative atomic mass was introduced. Relative atomic mass means to compare with a known or a standard one. For expressing the relative atomic mass of any element, a standard mass is necessary, and that the standard mass is 1/12 mass of C12 atom. Imagine a fruit vendor sells watermelon fruits by pieces. For making watermelon fruit into pieces, he does not have any standard weight with him, or he cannot cut into the same size. He makes the watermelon fruit into 12, of course, almost equal pieces, and says that the total mass of the watermelon fruit has 12 mass units. Now he sells his watermelon fruits by relative fruit mass units. So here watermelon fruit is cut into 12 pieces, and one piece is kept on the right side of the pan, and on the left side, whosoever the mass to be found, it is kept on the left side. Therefore, if both the pans occupy equal positions, then we can say that the mass of these unknown objects is equal to 1 fruit mass unit of watermelon. Of course, if we take one more example, imagine a big block which is divided into 8 small blocks. Therefore, one big block equal to 8 small blocks. Thus, the one small block mass is equal to 1/8 of the big block. If it is considered as a scale of measurement of the mass, then mass of any object is expressed as the number of times heavier than 1/8 of this small block. Now, relative atomic mass of any element is considered with 1/12 mass of C12 atom as we stated in the previous slide. Thus, the atomic mass unit is a mass equal to 1/12 mass. So, 1/12 mass of C12 atom is considered as 1 atomic mass unit AMU. So, relative atomic mass of any element is expressed as the number of times heavier than 1/12 mass of C12 atom. Relative atomic mass of sodium is 23. That is, each sodium atom is 23 times heavier than 1/12 mass of C12 atom. Thus, 1/12 mass of C12 atom is taken as a standard unit to measure the atomic masses, and this unit is referred as atomic mass unit AMU or simply mass unit U. Relative atomic mass of certain elements are given here. Hydrogen H, relative atomic mass is 1 unit. Helium of 4. Lithium relative atomic mass is 7. Relative atomic mass of beryllium as 9. Relative atomic mass is also referred as RAM. So RAM of boron is 11. RAM of carbon is 12. RAM of nitrogen is 14. RAM of oxygen is 16. Relative atomic mass of fluorine is 19. Relative atomic mass of neon Ne 20. Sodium 23. Magnesium 24. Aluminum 27. Silicon 29. Relative atomic mass of phosphorus is 31. Sulfur 32. Chlorine 35.5. Argon 40. Relative atomic mass of potassium is 39 and that of calcium is 40. So, you read all these elements with relative atomic masses every day for 5 minutes. You will recollect all these elements with relative atomic masses. Relative atomic masses of some more elements. Chromium 48, manganese 55, iron 56, copper 63.5, zinc 65, bromine 87, iodine 127, lead 208. Formula unit mass. Let us calculate the formula unit mass of H2SO4. So, we take this in a tabular form: element, number of atoms into atomic mass, total mass. Hydrogen, 2 atoms are there in this formula, 2 into 1, that is 2. Sulfur has only 1 atom into 32 equal to 32. Oxygen has 4 atoms, 4 into 16. Atomic mass of oxygen is 16, 4 into 16, 64. Total formula unit mass is 98 units. Now let us find the formula unit mass of some more elements. Sodium chloride NaCl. So here one sodium atom is there, one chlorine atom is there. Mass of one sodium atom is 23. Mass of one chlorine atom is 35.5. Therefore, formula unit mass of sodium chloride is 58.5. Let us take one more substance, potassium nitrate KNO3. KNO3 potassium nitrate has one potassium atom, one nitrogen atom, 3 oxygen atoms. 1 into 39, 1 into 14, 3 into 16, totally it is 101 units. Therefore, formula unit mass of potassium nitrate is 101 units. Formula unit mass of ammonium sulfate. Formula of ammonium sulfate is NH4 taken twice SO4. This has nitrogen 2 atoms, hydrogen 2 fours 8 atoms, sulfur 1 atom and oxygen 4 atoms. So here 2 into 14 28, 8 into 1 8, 1 into 32 32, 4 into 16 64. Totally the formula unit mass of potassium nitrate is 132 units. Formula unit mass of element nitrogen. See, this is a diatomic molecule. Molecule has 2 atoms. 2 into atomic mass of nitrogen is 14. 2 into 14 28 units. Formula mass of mass is also called as molecular mass. So molecular mass of chlorine, 2 atoms into atomic mass of chlorine 35.5, it is 71 units. Molecular mass of ammonia NH3, 1 atom of nitrogen and 3 atoms of hydrogen, totally 14 plus 3, 17 units. Gram atomic mass. The formula unit mass. If the formula unit mass is expressed in terms of grams, it is called gram atomic mass, GAM. Atomic mass of sodium is 23. If 23 is expressed in terms of grams, it is called gram atomic mass of sodium. Therefore, 1 gram atomic mass of sodium is 23 grams. Atomic mass of oxygen atom is 16. Thus, 16 grams of oxygen is 1 gram atomic mass of oxygen atom. Gram molecular mass, GMM. If the molecular mass is expressed in terms of grams, molecular mass means a molecule of an element or molecule of a compound. So, formula unit mass or molecular mass is expressed in terms of grams, it is called gram molecular mass. Oxygen molecule is O2. Its molecular mass is 32 units. Therefore, 32 units of oxygen is referred as 1 gram molecular mass of oxygen. Thus, we can find the GMM or GAM of any element or compound. Let us find the molecular mass of following substances: nitric acid HNO3, calcium hydroxide, iron 3 chloride, barium carbonate, silver nitrate, sodium chlorate, hydrochloric acid, magnesium hydroxide, lead iodide, potassium bromide, zinc sulfate. Let us know mole concept. What is mole? In the reaction of burning of sulfur, one sulfur atom reacts with one molecule of oxygen to form sulfur dioxide molecule. So, one sulfur atom combines with one molecule of oxygen to form one molecule of sulfur dioxide. Or 32 units of sulfur atoms combine with 32 units of oxygen molecules to form 64 units of sulfur dioxide molecules. From the above discussion, it is understood that the quantity of the substance is characterized by its mass or number of molecules to be shown in the equation. A chemical reaction indicates the number of atoms or molecules directly take part in the reaction. If we take the number of atoms or molecules as mentioned in the chemical equation, it's very difficult to find the mass of such a small number of atoms or molecules. Therefore, we have to consider a large number of molecules. So, it's more convenient to take a large and fixed number of molecules. Avogadro, an Italian scientist, proposed that a fixed number is 6.022 into 10 to the power 23. Either atoms or molecules of any substance has a mass equal to its formula mass expressed in terms of grams. Formula mass expressed in terms of grams is nothing but gram atomic mass or gram molecular mass. Thus, the quantity of the substance equal to Avogadro number of atoms or molecules is known as a mole. Therefore, 6.022 into 10 to the power 23 of 23 atoms of sodium is referred as 1 mole of sodium atoms, and 1 mole of sodium is equal to 23 grams. So, 1 mole of molecules or 1 mole of atoms is nothing but 6.022 into 10 to the power 23 number of atoms or molecules. Therefore, it is molecular mass in terms of grams or molecular mass of an element in terms of grams. Atomic mass of an element or molecular mass of a compound expressed in terms of grams is known as molar mass. Thus, molecular mass of sulfuric acid, that is H2SO4, is 98 units. So, 98 units of sulfuric acid is referred as 1 mole of sulfuric acid. In the next module, we can do some numericals involving moles, number of moles, and finding the molar mass of a given substance. Thank you.